In this video, I'm going to look at an HTML page with an SVG element that's empty and then use some JavaScript code to inside draw a pair. So first I started off with a tutorial on drawing a pair by Sandrine Maugy. Sorry if I'm mispronouncing that. Um, and it discusses the sort of you draw an axis. There's also a YouTube version. You have some axis, could be straight, could be curved. You draw sort of a circle in the top region that she'll refer to as the head, and a larger circle at the bottom called the body, and then make some connection between the head and the body, which of course the neck. Okay. And so here is my version made in code. And then, but I've got it a bunch of sort of random parameters so it can draw many pairs, sort of very elongated pairs, very squat kind of pairs. Okay. So here we go. All right. So here is just the HTML page. Here are my references to Sandrine. The style is just establishing a size and then styling the SVG based on that size. So this is half of the size. And then I did some kind of drop shadow around my shape. Okay. I was doing lots of angle things and pi was coming up all over the place. And so instead of doing Math.pi a million times, which is what I started off doing, I just got it once as a variable, a local variable pi, and then did that. Okay. And then M is me going up to my style and grabbing that half size. And so that's a parameter. Now, the first thing I want to do is if I'm following those instructions is to make the axis. So I'm going to, and the axis might be curved. So I wanted 3 points. I'm going to, in this case, use a quadratic Bezier. So I'm going to have 3 points, a starting point, an ending point, and a middle control point. And each point is an X and a Y. I'm in 2 dimensions. And my X's are always sort of toward the middle. So my width is 2m. So I'm going over 5/6 of an m, which is a little bit shy of the middle point halfway. And then I have a random number, which is a third. So I'm sort of, so this is somewhere in the middle, and my x's are all somewhere in the middle. Different values, somewhere in the middle, but somewhere in the middle. Whereas my y's, I have a y that's close to the top, a y that's the same as the x in the middle, and then I have a y that's near the bottom, except I can't spell bottom. Okay. So, and then here is creating a path in SVG has an attribute D, and here I'm using a quadratic Bezier path. So M tells me the starting point of my path, and I'm using that point at the top. And then the Q signifies that I'm going to do a quadratic Bezier, and the capital Q means I'm going to have like full on points rather than work with differences. So capital Q, and then my A2X, A2Y, and then finally my ending point, A3X and A3Y, and then I made the path and made that D attribute with no fill and made it green and added it to my path. And so you can see there is my green axis, my green axis, my green axis, which can, it's usually curved, but it's sometimes curved a lot, sometimes curved very little. Okay. And you would probably sort of not draw this or overwrite it in some kind of final picture, but I wanted to sort of show that I am following the tutorial. Okay. Um, Now I did take uh, those points, especially the A1 and A2, and sort of go a little bit beyond my axis, a little bit below my axis, a little bit below my top and a little bit above my top, but in along the direction that I have at the top, and I use that to make my stem. So you see here this green axis, that this green line was that axis. And then I made this sort of, I don't know, dark reddish brown um, line a little bit below, a little bit above. And so that I'm calling my stem. And that was just simply did a line. If I wanted to be, have a fancier stem, I might make it a little bit longer, a little bit curved. I just have this stubby little stem sticking straight along my axis. Okay. Now I start to make the head. And again, the axis is this Bezier curve. And when you're working with Bezier, you have a parameter t that moves from 0 to 1 as you go from your starting point to your ending point, your anchor points, the points that are actually on the curve. And so when you start off with 0, you're at your first anchor. When you end up at 1, you're at your second anchor. And then for small t's, you're sort of moving away from your first anchor toward the middle point. And then for values close to 1, you seem to be moving from your control point, that middle point, to the final anchor. Okay. And so I'm just taking advantage of this idea of t, and I wanted to make uh, the head sort of take up a fraction of this t range. So again, the Bezier curve has a parameter t that runs from 0 to 1, and I'm just making some fraction of that. So at least 20%, up to maybe 25%. And so I'm just choosing a random number, 0.05 plus a 0.2. So it's always at least, so it's a number that varies between 0.2 and 0.25. So, a fifth and a fourth. So this head size should be between a fifth and a fourth of that distance t. Okay. Now I actually wanted to find half of that because I'm looking for this. That's going to be sort of the amount that the head's going to take up, but I'm looking for the center of the head. And so I took half of that. So I found the t at half of that fraction. And I'm actually sort of playing the Bezier game sort of explicitly. So it's 1 minus t squared times the first number plus 2 times t times 1 minus t for the middle number and t squared for the final number, and do that for x and y. So that's finding me my center point for the head. And now I wanted to find the radius, and I just used the verticals here because my line's curved and it would go into all the length of curve and all that. So I'm just using for my radius the head minus the y's head, the center of the head's y, the y of the center of the head, and the y of the sort of top point of the axis. And that would be the radius of the head. Okay. And I wanted to also find the sort of the angle that the axis is making with the vertical. So I put in, I changed my t. I had a t. I changed it by a little bit. I just chose randomly 0.05 and got a new a new delta x and delta y. Sort of, I stuck it into the formula again, And this time, so at t, I was getting the head, but now I'm putting a t, changing t a little bit, putting it back in to the equation, then subtracting off the head. So I have a sort of a delta x and a delta t, and I did an arctangent, but I have x over y. So this is an angle with respect to the vertical. So this is the angle that the head is making with the vertical. And just so I didn't want to always assume that I was vertical. So you'll see this head angle popping its head in later. And then I'm drawing the circle. So I make a circle with the center head x, head cx, head cy, head r for the radius. I did not fill it. I made the stroke black and added it. And so you can see that here. Now, if I in the final drawing, I'm filling in my pear shape in with something with not full opacity, so you can sort of see through it and see this head circle. But you would probably not, in a final drawing, not want to draw the head. It's something that gets drawn and then erased. So in code, I could just not draw it, or put its opacity to 0. Or I might use it, not have any stroke, but I might have a fill that had some opacity. I mean, had a low opacity to do maybe a little shading of, sort of to get that sort of, that head is sort of supposed to represent some spherical shape at the top of the pear. Okay, now I take what I did for the head of the pear and do it for the body of the pear, but a little bit in reverse. One, I'm going to work from the bottom up with the body of the pear, but also I'm going to, with the head, I started with a T and then finally found a radius, and I'm going to do the opposite here. I want to make sure that my body radius is significantly bigger than my head. So here I have my head radius, and I'm multiplying it by at least 2.3. And then I also had a random number so that all my pairs look a little bit different. And I was always playing with these numbers, so I know it's a little ridiculous to multiply by 1, but that wasn't always a 1. Sometimes it was a 1.1, a 1.2. I was playing with these numbers to, and trying to pick numbers that always, at least to my brain, looked pair-like. Okay. But so now I'm making a body radius that is some multiple between 2.3 and 3.3 times the size of the head radius. And then I'm finding out the center vertically of the body. So just moving up from the bottom point and subtracting off the radius, that gets me my center vertical. And now up here, when I grabbed a T, where did I do that in my head? I got a T, and then I got a CX and a CY, and I got the radius from some equation after I put in T's. Now I would like to find the T's. And so I have to solve that same kind of equation I had above. And so it's going to be a quadratic formula. It is, after all, the quadratic Bezier. So if I want to find a T, I have to expect to solve a quadratic formula. And so here are my A, B, and C in terms of sort of like if I make a quadratic formula and solve it for T, these are my coefficient of the square term, the linear term, the constant term. And then I use one of the solutions to the quadratic formula to find the T. And then I can find the fraction that is the fraction of my axis parameter T then is taking up, then it's taking up, and also find the center, the horizontal center, by using that T. Okay. And then also, once again, play the game where I change T by a little bit and find this this angle because I do have this curved axis. So my axis is not completely vertical. Okay. And then I'm drawing the body circle, same thing. Body CX, body CY, body R. And we see that in the picture. And again, I probably take that out of some kind of final thing, but I want to show you my thought process here. And now I have to make the neck, connect the head to the body, and I'm going to use a cubic Bezier for that. So I'm going to draw the shape all around. I'm going to create the shape. I'm going to draw an arc across the top of the head. This is going to be a cubic Bezier. Cubic Bezier is going to allow me to match slopes at the top and the bottom. And then I'm going to draw an arc of the body and another cubic Bezier. So that's how I'm going to create this. This K is going to be some parameters. So you have these sort of in cubic Bezier, you have these you have these two slopes, the beginning slope and the end slope. And then you have points that are along those slopes, and then K determines sort of how much along the slope do you want to keep. And so I didn't have any good math to say I should pick this particular value, so I made it random between 0.3 and 0.4. I did not want to draw the entire head. I didn't want to draw an entire semicircle for the head. So I have an angle that I'm sort of cutting it off. And then down in the bottom, I wanted to use more than a full semicircle. And so I had another angle. Let me show you in this picture. Okay. So I'm going to draw, I have some angle, and I am going to go from, I'm going to start over here on the right and go over to the left. And this is the roll. So if I start on the right and go to the left, and remember, angles go down here, you can barely see. I have increasing angles go clockwise when you're doing sort of computer geometry. So a negative angle sort of comes up. Okay, so if I start here, when I draw this thing, I'm gonna start at sort of a negative angle, and then I'm gonna go over to, if I went, again, I usually move, positive angles move in this direction. So to get to its sort of reflection over here, that would be pi plus that angle. And that's going to get me this sort of not quite full semicircle, a little bit shy of a semicircle for my head arc. If I do the same game, but start on the bottom, but if I start on the bottom, if I start on the left and go to the right, then that same idea of pi plus theta over to minus theta, that's going to get me more than a semicircle. Okay. So that's what this is. This is some angle for how much of the angle am I shaving off in the head, and how much am I adding in for the bottom. So I'm never doing quite a semicircle. I'm not doing half a circle. I'm doing for the head a little bit less, for the body a little bit more, and with a little bit of randomness thrown in so that all my pairs are a little bit different. Okay, so here I'm starting. It's just going to be one great big path, and I can switch in paths. So I'm going to sometimes be drawing arcs and sometimes be drawing cubic Beziers, and it allows me in one great big path to sort of switch my sort of path modes. Okay, M is where I start, and I'm going to vertically horizontally the center of the head, and I'm adding the radius times math cosine. And I'm subtracting off a little bit of the angle. And then I also have the negative of my head angle in there because I'm not completely vertical. And then the same thing for y, and that's my starting point. So that's sort of somewhere over here. And then I am making an arc. The radius, making a circular arc. Arcs can be elliptical. So the radii don't have to be the same, but I'm making them the same, just HR. And then there are these parameters when you're drawing arc. And in this case, especially because I have less than a semicircle, I have my parameters here are 0, 0, 0. These are either zeros or ones. And so you can, um, you know, sometimes if I'm very confused, and I sometimes am, then there are 8 possibilities, and I'll just kind of go 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Which of these things do I want? And for this one, I want 0, 0, 0. And for the bottom, for the body part, we'll see we change one of them. Because if the semicircle is if the arc is smaller than a half circle, that's what one of those parameters controls. So we will see it change from the head to the body. Okay. And then this is my ending point. And so I started over here, sort of minus theta, and then here was my pi plus theta, but then everything with the head angle. And that's what I was showing again in this picture. I'm going from minus theta over to pi plus theta, and that is that. So here's minus theta, here's pi plus theta. That is that top of the head. Okay. Now I carry on. When you carry on in a path, you don't have an M because you're just continuing on from where your last point before. And the C here means that I'm making a cubic Bezier. Up above, when I made the axis, that axis was a quartic Bezier, and I had Q. Here I have C. So I'm going to have 2 control points. And I wanted control points that continued the slope of the arc. And so that's what this green thing is for. So here I just made this red, I made that arc, and then I want to continue that slope. Well, then I just wanted to know the direction of the slope. So I sort of translated that green arrow over here to the center. And I hope you can sort of see in there that starting at this dashed line and going in the clockwise direction, that this is sort of pi on 2 plus that theta. I'm not going to do all the math in as much detail, but just want to give you an idea, at least as starting. So here was, here's the point where I was at, and then I add a little bit, this k parameter, times that sort of green, uh, axis. So that is a cosine of half a pi. So this was pi, this was half a pi. So this was getting me to that end red point. That's not what I wanted. This is the one I wanted. But first I get to the red point, and then I add a little bit of sort of k amount of this unit vector, this green unit vector. Well, not quite unit vector because I multiplied by head r. Okay, so that is that reasoning, and then the same thing for the y. So that just gives me some smoothness. I have, when I draw my 2 arcs, my arc for my head and my arc for my bottom, then I don't want any sort of kinky points where the slope is changing. So that's why I like for this part, for the neck, cubic Bezier, because I have 2 slopes I can control. And so that was the first control. The second control, I'm doing sort of what I did for the head with the body. So here's the final point, which is a point on the body. And then here is down here, I should say, this is the final point on the body. So I'm here on the body. And then I need some slope that I'm coming from. And that was 1.5 times pi. Because here, let me draw here's my picture. So here I convinced you, I hope, that this was pi on 2 plus theta. But now when I'm sort of on the body, I could say I need to subtract, or this pi on 2, I end up with another pi. So I kept the same. I wanted to get this angle in the other direction, so I added like another pi to it. So that's how I ended up here with 1.5 pi. Or 2 pi goes all the way around the circle, so I could do half a pi, or I could also have just subtracted this thing. So there are a number of ways I could have done this logic. This is what I came up with. Okay, so this is continuing the slope of the head arc. This is getting me going in the direction of the body arc slope. And then this is the point I'm picking up on the body's arc. So now I'm down here. Now I make the arc with the body radius. Here I've switched to 0, 1, 0 because I am more than a semicircle. And that was that parameter there. 1 made it, is informing that I want more than a semicircle when I give the points. And then here's my ending point. And so I'm minus theta and minus theta. And that is getting me sort of over here. Remember, with the bottom, with the body, I'm going sort of from here to here. So this showed in red was the top. Now I'm grabbing the other side, sort of. So I'm starting from left to right. So now I'm doing more than a semicircle. And that was here, the second arc, the body arc. Now I've got to match up the Bezier to where I started off with. And so this was the slope. This is me continuing the slope of the arc from the body. This is me setting up the slope of the arc from the head I'm connecting to. And then this is finally the same point I started with, so I closed. Now there is a parameter in paths, part of T, where you can explicitly say I am closing. All right. Now what? I'm choosing a color, a hue for a color between 60 and 120. This is in the sort of yellow-green range. I am making a radial gradient. Gradients and radial gradients have these things called stops. I'm just going to have 2 stops. And I'm just making, just using HSL color model and making the second stop darker. So I'm going to have a radius where it's darker on the outside. So my pear is a little bit lighter in the middle and darker around the edges due to that radial gradient. I make the whole path. Here I'm making the opacity half so I can see my axis, my circles. I'm making the stroke blue. The stroke width 3. I would probably take out, here's giving it a class of shadow. That was that drop down shadow. I'd probably not have an opacity. I'd probably go on for so if I take out the opacity and take out the stroke, I'll be closer to sort of drawing a full-on pear. You can still see this black outline. That is my arc. So I would get rid of my arc or do something else with my arc. All right. And then finally, what I did is here's a function that makes a different radial gradient and makes a rectangle. And I called that at the top, but it was commented out, and that gives me a background. So let me find that and bring that back. So now I'm calling the function at the bottom, and it set up a radial gradient. No, of course, they both came out to be green. Okay, so that magenta purpley background has a gradient. It's not too obvious there. And then the pear also has a radial gradient. And so this is my pear drawing program based on the tutorial about drawing the axis, the head, and the body, and then connecting them with this neck. So that's what I want to show you on this one. Thanks for your attention.